This is the iPad which actually helps to record whatever I do in the class. So you guys are not getting recorded, it's only me and the board. And the reason being, this recording is meant for you guys to be able to revise what we do in the class. What that means is, you don't really have to worry about taking notes and being concerned about being able to note everything and not being able to note anything. So that you put your full focus and energy on understanding or following the concepts. Anything that you miss is understood. So it goes on to YouTube. Not trying to become a YouTuber, it's only 5 minutes. Alright? So let's do a quick roll call and see who all we have. And then we'll get started. So we have Dave, Danvin, Neil, Rehan, Ria, Ritika, Sara, Saranya, Sriyan and Tansi. Some of the kids are still missing. Chris has joined. Hey Chris. So hello everybody, let's get started. Talvi? In the classroom we have Praneet, Davik, Sahit, Nishka, Nirunya and Ashmita. I'm not getting that old. So far memory is with me. Alright. So I'm assuming that you all have got a chance to see the topic that we are going to cover today. If not, let me read that for you. So we are going to talk about the circle theorems. So we'll start with circle theorems. We'll try and understand what do we mean by sector, segment and arc of a circle, and how do we use different concepts to deal with them, and then we'll do some practice problems. And I'm hoping that everybody is able to follow me. Everybody can hear me okay on the screen?
Yeah.
Okay, good. So I know all the kids online might be thinking that we just missed the t-shirts, but we'll get it printed for you guys also, and you guys will get that in the subsequent months. Okay? Alright? So my monthly budget is to print 10 t-shirts a month. 11th one will come next month. Alright? So let's get started. So we'll start with circle theorem, try understanding the basic concepts, and then we will go to the trigonometry part of the circle theorem as well. Now circle theorem, what do you mean by circle theorem? Anybody, give me that English part of it. Math I will convert it to. What is your understanding of circle theorem? And don't be shy, okay? See how I'll not use the word seamless, but I have no hesitation with respect to speaking what I think. So I want you guys to be equally transparent and honest with me. It's okay. Making a mistake is no crime. Yeah, this car. Go ahead with that. No? Circle theorem. Anybody on the screen? What do you mean by circle theorem? Hey Tanu. I mean I said Tanu because I did not say hello to Tanu before. She joined just now. But the question to everybody is, what is your understanding of a circle theorem? Anybody? Guys. Okay, what do you mean by theorem? Okay, maybe I'm using my strong Indian accent, that's why you guys are not able to follow it. So I'll put the spelling in front of you. What do you mean by theorem? Theorems are nothing but proven concepts that you can rely on. Okay? Like you say 2 plus 2 is 4. That is proven till rest of my life and for all of you. Yeah? 2 plus 2 will never change to 5. No matter who becomes the president next time. Yeah? So theorems are the concepts that is proven to be relied on. Some of you would have come across the theorem of congruence for triangles. Yeah? Those are whoever remembers it, wonderful. Whoever doesn't remember it, don't worry about it. We'll come back to it. We'll keep coming back to the concept that we learned, and anything that is slipping your mind, don't worry about it. So these are the theorems of congruence of triangles if I pick one of them SSS, that says two triangles will be congruent if the three sides match. Meaning this side matches with this side matches with this one, and this side matches with this one. These are congruent, meaning every other property of these two triangles will match. Everybody? Neil, Sarah, Ritika? Everybody? So, any theorem that you talk about, those are the mathematical concepts that are proven and can be believed. Okay? Now, let's go back to, I'm not trying to confuse you guys with circle theorem and then take you back to the theorem of congruence of triangles. Now you should look at this without being worried about maths. It's English. Circle is circle. Like my face. Yeah? No denying it, right? You guys can see it round, right in front of you. Circle. And theorem is proven concepts. So now, we are saying that circle theorem is nothing but the proven concepts around property of circles. Should not be any doubt, right? I gave you the right example of a theorem and a circle. Yeah? Everybody with me? Ritika, does my face look like a circle? See, you're on the spot now. You can say, okay, but nothing wrong. It's fine, as long as you're not making fun of me, it's fine. Yeah? Rehan, can you dare to say my face looks like a circle? You guys are too shy. Okay. Dhanvin and Chris, no confusion with respect to what is the starting point for circle theorem, right? If somebody says let's talk about circle theorem, you can make out what exactly they want to talk about, right? So proven concepts of circle. This is a circle. What are the things that you guys know about circle? I might be asking a very stupid and easy looking problem, but that is the base. What comes to your mind when you talk about a circle? First thing.
The distance from the center of the circumference is the radius. The distance from the center.
Learn the art of being louder.
The distance from the center of the circle to any point on the circumference is the radius.
Yeah. Okay. Anybody on the screen? When anybody talks about the circle, what is the first thing that comes to your mind about the property of a circle? Yes, Shreya.
Well, it has no sides. It's when I think about a circle, I'm thinking about the radius and the diameter of it.
Okay. Dave, any other point? Okay. How about you, Ria? Endless number of points. Anybody here in the class? Participate with me. That's how you'll enjoy math. Yep. Go ahead. Oh, okay. There's an alert. Kids who join the first time, they become an obvious victim. Hasrita will say what I'm saying, right? And when I keep asking you this question, that is just to make you comfortable, first of all. Second thing is to get as much information I can get from you guys, because that gives me a starting point. That's what I'm asking question. Okay? I'm not trying to put anybody on the spot. You guys are all my kids, okay? Yeah. Okay. Yeah.
The angle of the circle is the distance.
Exactly. So now these are things that we know about. Okay? When you talk about circle, it's a round shape, and the only property that we need to know, apart from one thing that I mentioned at the beginning, is it revolves around a point called center, and that center is equidistant from any and every point on the perimeter, and that distance is called radius. So if you want to know about a circle, you just need to know how big is the radius. 1 centimeter circle versus 10 centimeter circle, all is a function of the radius. So radius is the only property that we need to know of. Yeah? I know I might be repeating these concepts for Neil, Sarah, Rehan, Ritika, many of you, right? Who have been tortured by me in the past, but I'm just repeating myself. Okay? So if you talk about a circle, you're talking about a round shape which has a center, and that center to any point on this perimeter is the same, that is called radius. Now I'm coming back to the area and perimeter. Who all remembers the formula? All of you? What is the area of a circle? Nobody should have any doubt, right? Is there a doubt? Pi r square to pi r, everybody remembers? Okay. See, Tansi said, sir, you are wasting everybody's time. We all remember it. And that's good. And there's a reason why I'm doing it, okay? So, area of a circle is 2 pi r square and perimeter is 2 pi r. Yeah? Now, and when we say perimeter of any shape, we are talking about the length of the boundary. When we say area, we are talking about the space that it takes. This is a starting point. Now let's get deeper into it. And these are basic concepts that we will remember and we will use them. Now, I took a circle which has center at O, and I picked up 2 points, A and B on the perimeter. Okay? Everybody can see what I'm doing on the board?
Yeah.
Okay. So I have drawn a circle with center at O, and I picked up 2 points on the perimeter, A and B. Now somebody is to tell me there are 3 terms that we'll talk about. One is this one. Let me color them. Let me color them. So if you look at the red part, if this has a name, if you look at this shaded region, the blue part, this has a name, and if you look at anything and everything that comes inside this green thing, that has a name. I want to know what are those called. When you look at this red curve like thing, what is that called? Kids, tell me what is that red thing called, which is along the perimeter? Arc. This is called arc. When you look at the blue shade, I mean the shaded region that I've put here, that is called something. What is that called? Yes, Ritika. Louder. Segment. Okay? So this is called arc and this is called segment. And anything and everything inside these 2 lines that were connecting to the point A and B, anything and everything inside that is called sector. So far we are dealing with easy ones. Okay? We are just knowing the name. It's like you have just come to the class and you know the name of the teacher. You don't really know what the teacher is going to do so far. Okay? So we know when you look at a circle, so we were talking about the properties of circle. We talked about what is radius. Circle revolves around the center, and the property is that from the center, any point on the perimeter remains the same. That is called radius, and we see it here now. Okay. So we went a little further. We said, okay, fine. Let's not look at the entire circle. We are looking at 2 points in the perimeter A and B. When I join these 2 points directly, then I see there is a shaded region underneath, that is in blue, that is called segment. The point connecting A and B along the perimeter is called arc, and this region is called sector. Sector, segment, and arc. Yeah. Now, you might, like we always say, right? The glass is half full versus half empty. Same way, See, these 2 points are along the perimeter. So if you have to look at the arc, you can say this red one is the arc, or you will say, okay, A and B can be connected along the perimeter this way also, right? That's the larger arc. Similarly, when you look at this as a sector, you will always say A and B has, this is minor sector, this is the major sector. Minor arc, major arc. Major segment, minor segment, major segment. So this is all the story. Let's get to the math. Are we okay so far? Dhanvin, Chris,
Yeah.
Sian, Thanu. Thanu, what happened, beta? Are you upset with me? Not saying anything so far? All good?
Yeah.
Okay, alright. So, we just learned what is sector, what is arc, and what is segment. Now, let's get into the rigor. So, this is my circle. This looks more like an egg. Yeah. So, sometimes you have to deal with my drawing skills, which is not great apparently, but we'll make it somewhat understandable. So, this is a circle. Now, I'm saying, I have 2 point A and let's say this is B. There is one more point that Pranit mentioned when he was describing the circle. He said that the circle makes a total angle of 360 degree along its center. Correct? So the total angle from here, if I start from here, make a complete circle, this angle from here to here, 360 degree. Okay? We'll use that information. Now I'm saying this angle is 70 degree, okay, and the radius is, let's say, 10 centimeter. Can somebody tell me? So basically, this is a circle where the radius is 10 centimeter. I have picked up 2 points A and B on the perimeter of the circle, which is making 70 degree at the center. Can somebody tell me what is the length of the arc? I'll come to you. Let me just check everybody on the screen. You guys got the question, right? I have a circle with radius 10 centimeter and I have picked up 2 points A and B along the perimeter, which is making an angle of 70 degree at the center. Can somebody tell me what is the length of the arc? Meaning A to B, this length. Since I am saying 70 degree, I am talking about this length. I am not talking about this. If I would have said 360 minus 72, 290, that would have been the larger arc. So I am talking about this arc from here to here, the minor arc. Okay. So I want to know the length of the arc and I want to know the length of the sector. Sorry, not length. Area of the sector. So I want to know length of the arc and area of the sector. Who all are ready to tell me what exactly it is? Or at least tell me how would you go about solving it. Don't tell me the answer first. I'll come to you, Pranit. I know you are super confident right now. He is already done. But everybody got the question, right? Neil, Sarah, Sriyan, Kanu, Dev, yeah, Priya. Now, I want somebody to tell me what will be the approach to find out the length of the arc and area of the sector. You don't have to give me the answer. Just tell me the approach. That's what I'm more interested in. Answers I don't care much anyways. Dhanvin, anybody, tell me how would you calculate this? What happened? Hasvita? Okay. No, I thought she's getting stressed out that this old man is bothering me so much. I'm just trying to see how would you think about it. That's more important. Okay. So guys, be ready with your story. Let me hear what Pranit has to say. Yep. So don't tell me the answer. Tell me the approach. That's what I'm going to discuss.
So to find the arc, you would use the normal 2 pi arc to find the entire circumference, and then multiply it by the angle divided by 360, which would give you the arc.
Okay.
Same with the center, except you use pi r squared.
Okay. Did you guys hear Praneet? Or you would want it to be louder hereafter? Louder? Little louder? Okay. Yeah. No, see, guys, and don't get me wrong. Okay? It is what you all will deal with when you grow up to my age, or little less than that also. When you are in a corporate setup, you would certainly want to be heard, and you will be heard only when you say it loud and clear. Okay? So that we all have to practice. I mean, I have practiced enough to be this loud that you all will go through the same. Yes, Ritika, tell me about it.
So to find the area of like the sector, you would do like the angle, which is 70 degrees, and put it over 360, which is like the total angles, and then you would multiply it by pi r squared to find like the area of the sector. And then to find the length of the arc, you would put the 70 degrees over 360 and then multiply by the circumference of the circle, which is 2 pi r.
Wonderful. Anybody here want to tell any story? Okay. What to do? It's only me as a confident storyteller. I want to groom you all to become a miniature of me in the longer run. Not with the length of the hair, but with the passion for the subject. Okay. What's going on? Huh? You guys are much better off. Let's not worry about it. I'll tell you guys a story later on when we have some free time. So, like the way some of you explained, right? I'm not really worried about the answer, but let's look at the concept part of it. If somebody says find out the arc, meaning here to here, this length. This length is a portion of the entire circle. Right? I mean, and this entire length is the perimeter. We are talking about a part of the perimeter. Correct? Similarly, if I am talking about the area of this sector, this area is nothing but, look at it like a pizza. We are talking about a slice of the pizza. Yeah? This is a pizza. This is Niska's slice. Yeah? No, I mean, normal scenario, right? Or maybe hospital. Whoever likes pizza more. So, this is a slice of it. So, how do you find how big is the slice against the size of the entire pizza? That's what we are trying to find out. Right? Similarly, when we talk about this length is nothing but a part of the entire perimeter that we see. And how do we see how big that part is? Yeah, part. So, here, everybody on the screen with me, right? Nikhil, Dhanvin, everybody. Yep. Keep enjoying my story, okay? Because that is what has the entire content. So I'm saying, when I'm talking about the arc, I'm talking about part of the entire perimeter. When I'm talking about the sector, I'm talking about some part of the entire area. And how big that area is, or how big that length is. If I'm talking about the entire perimeter, I'm essentially covering the entire angle of 360 degree. 360 degree is equal to entire perimeter. I'm trying to find out the arc right now. Okay? So when I'm covering the entire 360 degree, I'm covering the entire perimeter. Right now I'm covering how much? Started and continued till 70. So I only covered till 70. That is the length of the arc I'm talking about. If I would have covered the entire journey, it would have been 360 degrees, and which is equal to the perimeter. So 360 degree covers the entire perimeter. My radius is given as 10 centimeter. I'll put 10 centimeter. I'll write 10 centimeter also. Right? 2 into pi into 10 centimeter. So 360 degree covers the entire perimeter. 1 degree will be how much? So let's say 5 bananas cost you $10. 1 banana will cost you 10 by 5, right? So 360 degree is this much. So 1 degree will be equal to 2 pi into 10 centimeter divided by 360. If you are talking about 70 degree, We are talking about 2 pi into 10 by 360 into 70. Cost of one apple, 70 apples. Yeah. I know I might be giving you a very simple approach, but let's keep it simple. That's the goal. Yeah. So are you able to relate? So I'm not asking you guys to memorize this formula. Okay, if you're talking about 60 degree, it will be 60 by 360 into 2 pi. No, I'm not saying this. Always relate it conceptually. Okay, entire perimeter is 360 degree. I'm talking about only 70 degree of it. So if this would have been 360 degree, that would have been 2 pi r. 1 degree is 2 pi r by 360. 70 degree will be this. Now you do the calculation. Now everybody knows pi is nothing but 22 by 7. So this gone 7. So 70 can become 7 into 10. So this 7 and this 7 gone. You have 2 into 10 into 22 by 36. Do the calculation, find it out. Yeah. Neil, start out with me. Nikhil,
Yes, sir. Yes, sir.
everybody with me? Okay. So we just saw how do you find out the arc of a circle. And I'm sure most of you are already aware of it. We just did it one more time and we'll do a few more of them while we are doing practice. In the same problem, if we had to find out the sector, this is 70 degree and this is 10 centimeter. When we are talking about a sector, what we are talking about? Part of the pizza that Nirnya had got, right? Your slice better? Yeah. So your slice is part of the entire pizza, which was distributed among the entire class. Entire class is 360 degree. That is the entire pizza, and that is the area, which is pi r square. R is nothing but 10. So 10 centimeter square. So 10 square and centimeter square. Yeah. 70 degree. Pi into 10 square centimeter square divided by 360. That would have been 1 degree, and now you multiply that by 70. You have it. Yeah. So area of a sector should not be a problem, right? Now comes another interesting part. Area of sector and area and length of the arc is okay. Let me make your life little difficult. Is that okay? See, if the teacher doesn't bother, it's not fun. Teacher should bother, right? Now let's look at it. This is a circle, and I'm saying that these 2 points A and B are making 60 degree at the center. And this radius is 10 centimeter. So these are the points A and B. I'm saying find out the area of the segment. One begins. How would you find the area of the segment now? Don't try finding it. Put your thoughts together. Think about it. Connect all the dots first, conceptually, before you try or before you attempt solving it. How would you go about it? Yes, Ritika. No, you just tell me the approach bit, okay? That's what I'm interested in, because no, if we are clear about the approach, everything else will fall in place.
Like maybe find like the area of the sector and subtract the area of the triangle.
So you, okay. So that's a very good starting point, right? What Ritika is saying is, you are trying to find out this red shaded region, right? She's saying, you find out the area of sector, that's what we found just now. Subtract the blue part, the green part. Meaning, you see a triangle here, right? Find out the area of the entire sector, subtract this area of the triangle. You're done. Yep. But how? Ritika, you are trapped, better, okay? Now you have to tell me how to find the area of the triangle. Yes.
Wait, I think it's like an isosceles triangle because like if both of them have like the radius, like
Give yourself 30 more seconds and then I would want to hear you better. You are going the right direction, but there's one more element that you're probably missing. And see, in this class, I will make you guys think, okay? Because that's when you there are some neurons in your brain, okay? That will be in a hibernation mode. When you wake them up, they do magic. So I'm just trying to wake those neurons up for everybody. Wake up neurons, wake up. So see now for everybody to think, okay? Riya, Dev, Sriyan, Dhanvin, Nikhil, Rayans, everybody, okay? The deal is that Ritika has given us a clue. She said, if you want to find out the area of this segment, it's easy peasy. Find out the area of this whole sector. We saw just now, 5 minutes ago. Find out the area of this sector, and then you see there is a triangle which is separating or taking out this portion, right, from the segment. If you did subtract this part from this entire sector, that the remainder is your area of the segment. So Ritika has given us a guidance here. Say, okay, find out the sector, area of the sector, find out the area of the triangle, subtract this area of the triangle. Let me write it down. Okay? So area of, let's say we say O, area of sector OAB minus area of triangle OAB will be the area of segment. Yeah? This part is okay. Now, the poor girl, she was guiding in the right direction. I said, okay, fine. I am agreeing to you. And I'm assuming everybody in the class agrees to what Ritika told us. Now the question is, okay, find out the area of this triangle now. How do you find out the area of the triangle?
So in order to find out the area of the triangle, first you need to prove that it's like. So first you need to figure out what the height is. So you have to split it into two, like from the top vertex in half, like bisected. So then you get 30, 60, 90 triangle with the side of 10, and then you can use trigonometry to get the middle part, and then you can find this.
Love it. Yes, that's the right approach. So now let's look at it. So we will not try finding out the area of the sector today, but we want to make sure that we are conceptually very clear about what is the approach. Okay, everybody on the screen, Dev, Riya, Ritika, are you ready with your continuation of the story?
well, yeah, I'm not gonna like solve the number of times.
No, you have to just tell me the how part of it. I don't want you to solve it.
So it's an isosceles triangle, so the A of is also equal to 10 because like all the radius that they come through it, and then you can draw like the height, all one draw the height, and then it creates two very 60-90 triangles. Like the base and the height and the
Actually, you are in the right direction, but you just missed one thing, okay? See, now if you look at this triangle OAB, it's an isosceles triangle is what you will think initially. Because these two sides are nothing but the radius of the circle. They will be equal. But I'm saying these are not isosceles, this is not an isosceles triangle, this is an equilateral triangle. Because if these two sides are same, that means this angle and this angle will be the same. What is the sum of these two angles? 120 degree. Because 120 plus 60, that makes it 180. And these two are same. So if it is x, this is also x. 2x is nothing but 120. How much is x? 60 degree. So all the angles are actually 60 degrees. So that's why I was asking you that this is not the isosceles triangle, this is actually an equilateral triangle. But the catch here is, whatever you are doing, you are actually still okay. You are not going wrong. It doesn't actually matter whether it's an isosceles triangle or equilateral triangle. What you are telling me is drop a perpendicular from here to here and it breaks into two congruent triangles. That's what Tariq was also saying. Yeah? So concept level, if you see, what we are trying to do is to find out the area of this triangle, we only know this part. When you drop a perpendicular here, you'll apply geometry to theorem of congruence to find this triangle and this triangle are same, congruent, and that way you'll find this length is equal to this length. When I said these are equilateral triangle, that tells me that length from here to here is also same. If this length is same, this angle and this angle are matching, this angle are anyways matching. So this will become a triangle like this is 10, this will become 5, this is 60 degree, this is 30 degree, and then as Danik said, we'll apply to find out the area of this triangle will be half into base into height. We found the base, we have to just find out the height. How will you find out the height? We'll find it using trigonometric ratios. Okay? You know, see, this is 60 degree. So if you are talking about, let's say this is x. So x divided by hypotenuse is sine 60 degree. Sine 60 degree is nothing but root 3 by 2. So x by 10 is root 3 by 2. So x becomes 10 into root 3 by 2. And you find it out. So you found the height. Now this area of this triangle will be half into base into height. So you found the area of this triangle, which will be, this whole triangle will be 2 times this area, multiplied and you get it. But I ran through this very quickly, so let's not worry about it. Because this problem has too many concepts. It has geometry in it, it has trigonometry in it, and what else? And then sine 60 degree is straight away said root 3 by 2. Some of you would not remember that also, right? It might be a little worrisome. I have proved that in the previous classes, but it's not easy to remember unless you practice it a couple of times. So we'll come back to this kind of problem or finding out the area of the segment in future classes. Let's look at some easy problems to begin with and then we'll come back to this. Tanu, Dalvin, Sian, Neil, Sarah, Saranya is also very quiet today. What happened to all okay?
Yeah.
Tansi, am I scaring you guys too much? So, okay, now whatever I discussed about the segment, let's not talk about that today. Let's practice a little bit on the sector and the arc so that we get more comfortable and then we jump onto something which is a mixture of a lot of concepts. Alright? So I had picked up few questions from the material I use for teaching you guys. Let's look at one problem. Are you guys ready? With neurons being awake? Okay. So let me draw something real quick. This is a circle. This is A, this is B, this is C, and this is D. 4 points on the perimeter of the circle. This angle is 35 degree. Okay. In this figure, O is the center of the circle, AC and BD are 2 diameters. AC and BD are 2 diameters. So these 2 are diameters. Okay. So this is, you can assume that this is the center of the circle. What is the measure of angle BAO? BAO, this angle. What is the value of this angle and what is the value of this angle? There are 2 questions that we have. Yes, Saranya, tell me.
I don't have an answer about everything.
Okay, with that. You will have to watch the video later on then.
Okay.
Yeah? Okay.
Sorry,
Yeah, bye with that.
The angle at C is 35 as well.
This is 35. How about this guy?
I'm still figuring it out.
Huh?
I'm still figuring it out.
So don't trust anybody, okay? They might go wrong. I tell all the kids that okay, don't trust your best friend also when it comes to solving math, because you will have your own approach. So think about it. Think about it. Anybody on the screen? So I have this circle. These are 4 points on the perimeter, such that if you join A and C, this is the diameter. When you join B and D, that is another diameter. And they are meeting at this point O. We have been asked to find out this angle and this angle. What is going in your mind, Nirunya and Hasmita? Your mind also, everybody. I'm just picking up some names, but yeah. Yes, Nikhil.
So can you put on your solution because I cannot see anything like on the first line.
Yeah.
It's really like super blurry.
Okay.
Like it's on the computer on the settings.
Okay. You're not going to see anything, is it?
Like I can see it, but it's very blurry. Like it's like really hard to make out.
Let me make it darker for you guys. Can you see the circle better now?
This is.
Can you see the...
This is. I
Okay.
can see it much better.
Okay. So here the deal is, this is a circle. Here are the 4 points A, B, C, D. This is A, this is B, this is C, and this is D. Such that if you join A and C, that is a diameter. When you join B and D, that is another diameter. So they are meeting at point O. Okay. So apparently O is the center. So we have been asked to find out the angle, this angle, and the value of this angle. You guys can also discuss among yourselves. That's okay. See how much collaboration they are having right now. You and I can discuss if you want. Okay. Nancy, Tanu, Sriyan, what's going on? Thinking. Ria. Thinking. So there are 2 problems, okay? So this is the circle where you are only given this angle is 35 degrees, and you are told that these 2 points, these 4 points, A, B, C, D are such that if you join A and C, that's a diameter. When you join B and D, that's a diameter. So they are meeting here. That will be the center of the circle in which way. Because now, if you look at it, right? If you have a circle, if I claim that these 2 are diameters, they will be meeting on the center. Yeah.
35. This one's 35.
That was 35. Okay. Do you guys believe him? Let's argue. I will anyways, I'm going to argue with him anyways, because I'm not going to be convinced that easily. So, anybody on the screen? Danvin, what's cooking up? I got 1 pair of answers. Discuss. Tell me that. Thinking. Okay. Let the first problem be solved by the teacher, okay? Here. Okay, can you tell me a reason why did you say both are 35?
Well,
So I came up with that. So if you look at A and B, and then you follow the lines up to O and don't go past that, you can see that that's a central angle. And since BA to B and like you see the angle, yeah. So that's like another angle. So 35 times 2 is 70. So that means the central angle should also be 70 because it's linked to the same area. And then from there I did 70 plus 70 because of the vertical thing. So 140. And then I did 360 minus 140, which is 220. And then I divided that by 2 to get O. And then I like added and then subtracted again.
Okay. Okay. Anybody else? You guys have any story to tell before I continue? So now it's my turn to bore you guys for next 2 minutes, or at least 1 minute, because I have an opportunity. I have Nirunya in the class for whom it is the first class. This guy has heard me before. There is one concept that I keep on stressing on, and that is what I have invented. I can patent this in future. Okay? This is 100th time for you. Sorry about that. So this. If you are in a race, whether you will win or not depends on how you ran. Yeah? And this ran here stands for R is for reading. I relate that in terms of how you solve a problem. Okay? When you have a problem to solve, read it once, twice, 3, 4 times. Once you have done enough reading and you are tired of it, then analyze with your thoughts. Okay, this is what I know. This is what I can think of. These are formulas I know. This is what I'm going to apply. Once you have read it, once you have analyzed it and you have a blueprint in your mind, then you come to Nike. Nike is the brand which says just do it. What it means in summary is read the problem, put your thoughts together, then you try attempting it. Because if you pick a problem and jump onto it, you might follow a wrong path, and then coming back from there and then picking the right one might waste a lot of time for you in the exam. Okay? That's why. And people who have heard it more than 50 times from me, the expectation is they would have started practicing it. That's what they were doing. And I was very happy seeing Davik and Pradeep talk to each other, because this is how I want you guys to learn things. Okay? When you learn something, when you discuss with your friends, you will see that you explore different options. Okay? So get into that habit, that helps. Now here, I read this problem so many times. Let me read one more time. I have a circle where A, B, C, D are 4 points such that A and C is a diameter, B and D is a diameter. And when I look at any circle, when I put 2 diameters, be it this one, they will always meet at the center. Yeah? Now let me do this in a very simple way. Now look at this. So this is my center. There was a reason why I was saying this is center. If this is a center, look at this triangle OAB first. OAB. This triangle OAB. This is a center. So from here to here, the distance will be same as here to here, the distance. Yeah? Both are radius, right? This is radius, this is radius. So if you look at this triangle, what is the name I can give to this triangle? Virendra Kumar? Isosceles triangle. Yeah? If it's isosceles triangle, that means this angle and this angle will be same. The angles along the matching sides. So this angle and this angle will be same. Straight answer 35 degree. Yeah? No, I saw you guys digging a big hole to find this out, and there's nothing wrong in that, because that helps you explore. But what I'm saying is, this is where my most boring concept, analysis, gives you that clue. When you look at this triangle, first thing that struck you is, oh, this is a radius, this is a radius. If I'm looking at only this triangle, do I find something? Oh yeah, this and this are matching. So it's an isosceles triangle. So this angle is angle will say, done. See the magic of that. I can predict it. Yeah? Are you guys with me? Was the first answer looking convincing to everybody on the screen? Yeah? Dave, Tansi, Tanu, everybody, right? Ritika? So, first thing is, these two angles were easy to find. Now hereafter, whenever you see in a circle, whenever you see a triangle, which is such that this is our center, by default it's an isosceles triangle. If it's an isosceles triangle, this angle and this angle have to match. Done. And I was able to come to this quickly because I've been seeing it for 30 years now. I mean, I've not been teaching for the last 30 years. But when I did this, when I was your age, maybe one of my kids who just opened the door. So, this is an isosceles triangle. So this angle and this angle are same. Now, let's look at how do you find out this angle. Next thing, this guy, when you stare this triangle very closely, okay? Stare. I mean, you are just changing this triangle now. These two triangles. You see two triangles, right? Triangle OAB and triangle OCD. In the first glance, it looks they are congruent. They are congruent for me. Why? Because see, this side and this side are radius, this side and this side are radius. All four are the radius of a same circle. So this length and this length and this length and this length are same. Yeah? Am I getting you guys concerned? Now? Ritika, are you with me, beta?
Yeah, I understand.
Okay. So basically here, as soon as you realize that this is the center, first thing you found that this side, they are all same. Because they are all radius. That was the first point I discussed. That's when I was boring you guys with something that you have been knowing for the last 5 years now. If you have a circle with a center, anything and everything is same. All the radius are same. That's the first property. And why we are kind of getting a little confused or it's taking more time to analyze because we are missing the most basic concept here. Everybody learns the table up to 13, 14, 15 and if you forget the table of 2, there's a problem. Yeah? This is the table of 2. So these four sides are matching. Now, other thing, if I have two lines meeting each other, the opposite angles are always the same. You see this angle and this angle will be the same. So between this triangle and this triangle, I can say applying SAS, they are congruent. Side, angle, side. That's the second theorem of congruence that says that if you have two triangles where the two sides and the angle between them match, so two sides and the angle between them, two sides and the angle between them, sides are matching, angles are matching. These are congruent triangles. This triangle and this triangle are congruent, meaning they have exactly matching properties. If this is 35, this is 35, by no means this can be anything different from 35. Why is that a good concept? So, I will lose at least 20 milliliters of water due to the summer. It's okay, I can manage. So here, did that make sense to you guys? Yeah? Riya, Ritika, Rehan, Nikhil, everybody? So, see again, I will repeat, request, I'll not say beg, that's not a good word, to make sure that you leverage this technique, okay? This comes for free. Okay? Meaning, this effort that goes in analyzing a problem, okay? Analyzing or collecting your thoughts, putting a structure to how you are going to approach, putting a method to the madness, right? That is worth investment, okay? That will make your calculation go much easier. Now look at this. I did not do any calculation because obviously I looked at this problem and I would have probably solved this 35 years ago. That's why I did not have to put that effort. But here, just by looking at this problem, looking at it very closely, I could make out that okay, these two are matching. Sides matching, how can we calculate? No big deal. Done. See, right now I'm discussing with you guys like you will discuss with your friends also, right? When you exchange a problem, hey, you are probably a couple of minutes early in the class. Let me wrap up this class before we start for you guys, okay? Just 2 more minutes. So you can assure, just as it is. Everybody wait for 2 more minutes. So this is the thing, okay? I will teach you guys the concept, right? And how you will get more used to it by finding friends. I was very happy when I heard that Nirunya is joining the class who is Hasvita's friend. Then I realized, okay, whatever we do in the class, Hasvita gets another opportunity to discuss with Nirunya, right? You guys are good friends. So when you discuss it among your friends, you will see that your concepts get much stronger. Okay? That's what I've been telling other kids. Even my elder daughter is about to go to college this year in few weeks. I used to wonder, like, why you guys don't discuss things with your friends? No, probably we don't follow that culture here. Maybe I'm too old. But then the deal is, when you discuss, here you're not going to discuss with me as often as you could discuss with your friends. So leverage your friendship to your benefit as well. To get stronger, more comfortable with the concepts. With that being said, I will take a pause. Any questions with respect to whatever we have heard today? We will, next class, no blabbering. I will make sure that we practice 3-4 more problems. I'll let you guys do some problems. And then we'll go on to finding the area of the segment. Okay? With that being said, I will let all the kids from SAT group go and I'll bother the kids, the younger ones.